Hello, this is Mr. Win, and this video is Quadrilaterals Part 3. We're going over trapezoids and kites. So back to our flowchart. Quadrilaterals, we finished the left side. We're now going to do the middle and right branches, the trapezoid and kite, and actually add one more. Add this shape, the isosceles trapezoid, and it comes from a trapezoid. It's just a special type, and I'll talk about that in a second. Also, notice the markings on this flowchart on each shape. They do mean something. The right angles, the equal side marks, the parallel line marks. So a trapezoid is a quadrilateral with exactly one pair of opposite sides that are parallel. If both pair of sides were parallel, that'd be a parallelogram. So there's a picture on my right. The parallel sides are called bases. So this is a base, and this is also a base. The non-parallel sides are called legs. So this is a leg, and this is also a leg. So legs are not parallel. The base angles are two consecutive angles whose common side is a base. So this right here and this right here are different angles, but those are base angles. And then use a different color. This right here, whatever it is, we'll call this A, and whatever this right here, B. Those are also base angles. So base angles are basically the side-by-side angles that are on the base itself. All right, so that's that. And the mid segment is a segment whose endpoints are the midpoints of the legs. So let me erase these. We have a mid segment, so we have a point, say here and here, where it is the midpoint of each leg. This line right here is called the mid segment. All right, and it actually is parallel to the one too, so I'll add that parallel mark. All right, so important properties. All quadrilateral properties are maintained, so still adds with 360 degrees, four sides of course. The non-base consecutive angles are supplementary. That means that's 180. So I always say top and bottom make 180. So let me make up some examples here. Let's say this right here is I'll use green, 80-degree angle. Then this has to be a 100-degree angle. Then maybe this is, say, a 120-degree angle. Then this has to be 60 degrees. The top and bottom make 180. So 100 plus 80 is 180. 120 plus 60 is 180. But if you go side by side, sideways, 100 and 120, that's 220. That doesn't do anything. And then 80 plus 60 is 140. That doesn't do anything. So only the non-base consecutive angles are supplementary. Also, the mid-segment will be the average, or half the sum, of the bases. So you add them up, divide by 2. All right, let's try a problem. In the trapezoid below, find the length of E to C. So notice E to C is a mid-segment because it's connecting midpoint. C is a midpoint of I to K, and E is a midpoint of P to L. So to find the midpoint, you just find the average. So X is going to equal, you add the top and bottom, and you divide by 2. So average, add all the things up, divide by the total number. So this will be 30 over 2, which is 15. So 15 is the average, or halfway, the middle of 12 and 18. All right, and here's a weird challenge problem that you might see. In the trapezoid below, what's the connection between angle MAH and angle AHT? So I extend the sides for y'all. Remember, this is a parallelogram. We have parallel lines. Let me draw it over here. We have two parallel lines and a transversal that cuts through it. So let me say I had this line cutting through it. Remember, we have alternate interior angles that are equal. So these angles are the same, and even these angles are the same if they exist in the picture. Now in our picture, only one of those angles exists, the red ones. The outer ones aren't there. So we can say this angle is the same as this angle. So you say they are congruent. That's the answer. Do not forget about your parallel lines and transversal. Our alternate angles are equal. Alternate interior angles are equal. Alternate exterior angles are equal. Corresponding angles are equal. Consecutive interior or same side interior are supplementary, in case you asked that. And notice, let me just draw the other one. if this existed, this angle right here would match this big angle right here, but again, that's outside our picture, so it doesn't really fully exist. So I'm gonna take rid of that. All right, so that's it for the trapezoid. Let's talk about the isosceles trapezoid. An isosceles trapezoid is just a trapezoid where the legs are congruent. They're equal to each other. That's why they have those tick marks that mean they're the same. Some important properties. All quadrilateral properties are maintained. All trapezoid properties are maintained. And then there's 3 new ones. Base angles are congruent. Remember, when you have an isosceles triangle, you have 2 equal angles. The angles are the same. So same thing here. So I'll make an angle up. Say this is, I don't know, 70 degrees. Then this will also have to be 70 degrees. Those are base angles. But the top are base angles too. So if this is 110 degrees, this is also 110 degrees. And top and bottom must make 180. But now all the angles are equal to the angles beside them. Opposite angles are 70 and 110 are opposite. So look, example, these are opposites. And then these are opposites. They are supplementary, add to 180. All right, and then last, diagonals. What do you know about diagonals? So let me draw them. I'll use blue. So this to this right here. And then this to this. You should be able to tell that they are the same. They're congruent. So they're equal. Alright, now they don't bisect each other or any of those other properties we learned from other shapes. Alright, next we have the kite. The kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So it's not quite a rhombus, it's not a diamond, but notice that these 2 sides over here are equal. They're the same marks. Then these 2, the long sides, are equal. That's what it means to have consecutive congruent sides. Alright, their important properties. All quadrilateral properties are maintained, meaning they have 360 on the inside. Exactly 1 pair of opposite angles are congruent. So here's what I mean. If I look at the picture, these 2 angles are exactly the same. So say this is 100 degrees. That means this is also 100 degrees. But the top and bottom angles are going to be different, and I'll just fill some numbers out. So maybe this is 120 degrees up here, and then this down here is going to be 40 degrees. Alright, so only 1 pair of opposite angles are the same. Next one, exactly 1 diagonal bisects a pair of opposite, let's see, angles. Oops. Alright, angles. What that means here is this. So I'm going to draw the diagonals. So here to here is the diagonal, and it's the vertex to the other vertex that does not actually go along with the side, and here's the other diagonal. If you look at these 2 diagonals, notice only 1 pair cuts angles in half. So that's the top and bottom one. If this is 120, then these are both 60s. If bottom's 40, and these are both 20s. Now, unfortunately, for the left right angle, those hundreds, those are not 50 and 50. Those are different angles. Alright, next one, diagonals are perpendicular. That means they make 9 degrees. These will be right triangles. When you see right triangle, you probably do trigonometry. So let me add those right angle marks right here. And actually, let's just see some common sense. If that's a right triangle top left, if that's a 90, that's a 60, then this must be 30 degrees. And then if that's 30, the whole thing's 100, I mean, this means must be 70. So see, they're not the same. Now, but the left side and the right side are 2 similar triangles, so this is also 30, and this is also 70. So that's how we broke up that 100. And last, exactly 1 diagonal is bisected. So which diagonal looks like it got cut in half? It's the shorter one. So this will match this, whatever that is. Alright, that's all the properties. Let's try a problem. In the kite below, L to U is 16. So L to U is this entire side. But that's the shorter diagonal. It's bisected, so half of 16 is 8. So I can say, oh, this is 8 and this is 8. All right, E to R is 15. This is 15. And A to E is 6. All right, find the perimeter of the kite. So perimeter means find all the outsides. So we also remember that these are all right triangles. The diagonals are perpendicular. So I'll draw that. Let's look at this top triangle. I'm going to highlight in blue. This top right triangle. All right, and I'll pull out right here. All right, we know this is 6, this is 8. We can do Pythagorean theorem. This is a triple, so I don't do work. That's going to be a 6, 8, 10. That's a 3, 4, 5 times 2. So if this is 10, this other side's 10, because those two sides are congruent. Or you can say the top left triangle and top right triangle are the same thing. It's just backwards. If I drew the other side, it would have been this. So it would have been 6, 8. It has to be 10. So the top two sides would be 10 and 10. LA is 10, AU is 10. All right, the bottom triangle, let's look at that. I'll do this. So I'll draw it out here for y'all. All right, we know this is 8. We know this is 15. We're trying to find this. Well, the good news is this is also another triple. This is a 8, 15, 17. But if you did not know that, you could do Pythagorean theorem. A squared plus B squared equals C squared. But they save you time. So if this is 17, this other side's 17. To find the perimeter, that's easy. You're going to add all them up. So we do 10 plus 10 plus 17 plus 17. Or you can do 10 times 2 plus 17 times 2. So what's that? It's 20 plus 34. That is 54. That's our perimeter. All right, so right here. Perimeter, I should start P, equals 34 units, whatever it is. All right, next it says find every angle, round all angles to the nearest whole number. So I'm actually going to find this angle here. I'll call this X. All right, if I do trig here, this is H, this is O, this is A. Let's use tangent. So I'll do a tangent of X equals O divided by A. I'm going to arctan both sides to X equals inverse tangent, or arctangent, of 6 over 8. And I'll type in the calculator and see what I get in a second. And just to save time, let's have the other one. For this other triangle, I'm going to find let's find this angle right here. Let's call this Y. So here's H, here's A, here's O. I'm going to use tangent again. Tangent is common for word problems. So tangent of Y is equal to O over A. I'm going to arctan both sides to get Y equals inverse tangent of 15 over 8. And I'm going to type it in the calculator and round, make sure I'm in degrees. And it says round to this whole number, so let's just use, well, I have this all ready for us. Let's see. All right, inverse tan of 6 over 8 is 36.8. But that 0.8 bumps to 37, so that's 37 degrees. And we're just rounding. And then the other one, arctan of 15 over 8, that's 61.9. That 0.9 does bump that 61 to 62. All right, once you know those, let's fill them in. If this is, let's see, this is 37 degrees. We know this is 37 degrees. We can do triangle sum. If that's 37, the top's going to be 53, because that's 180. So that's also 53. For the other triangle, y was 62, so if this is 62, we know this is also 62, and then triangle sum, 62 plus 28 makes 90, and then 90 plus 9 makes 180. All right, found that, and if you want the big angles, you just add them together. So 53 plus 53, the top angle, if you wanted it, that is 106 degrees. Bottom one, 28 plus 28, that is 56 degrees. The right, 37 plus 62, that is 99 degrees. On the left side, 37 plus 62, that's 99 degrees. All right, so there's everything. All right, last slide, quadrant review. Which quadrats have congruent diagonals? There are 3. That is the square, the rhombus, and, oops, I meant to say rectangle, and then isosceles trapezoid. To make sure you know that's a special one that has congruent diagonals. Then which quadrats have perpendicular diagonals? There's 3. That's the square, the rhombus, and the kite. All right, so make sure you know those 6. Then below is the Venn diagram. So you can use this instead of that color chart before to do the always, sometimes, never. So they're inside each other and going out. That is always true. If it's going inwards, they're sometimes true, and if they're different circles, they're never true. That's it. Thanks for watching. Bye.